What's up, everyone? Welcome back. Patrick here, and moving on to the next question, we got to find the domain of each function below. So notice we got three functions here, and notice that all three functions, they actually have the same denominators. This x plus 1 times x minus 2, it's the numerator that's different for all of them. So here we have the square root of x plus 2, here we have the square root of x, and here we have the square root of x minus 3. So starting with this first one, what's the domain going to be here? Well, notice there's going to be a couple of restrictions on x. I'm going to start off with the square root. Now, we know anything under a square root always has to be greater than or equal to 0. You can never square root a negative number. So we know that all the x values definitely have to be greater than or equal to -2 when we isolate for the x in this inequality here. But notice that also from the denominator, we could tell that x cannot equal -1, and then x cannot equal +2. Okay, so x has to be greater than or equal to -2, but it can't equal -1, it can't equal +2. So if we show this on a number line, basically what's going on, let's say this is 0 over here. So let's say -2 is over here. Notice it can be -2, right? It can be 0 because we could take 0 and divide it by a number. We just can't take a number and then divide it by 0. So -2 is inclusive in the domain. So we put a solid dot there. It can't be -1. So at -1, there's actually going to be a hole there. And then it can't be +2, so there's going to be a hole there as well. So basically the way it's going to look is like this. Then it's going to look like that. And then like that. Right? So that's the domain on a number line. Now if we were to show this in a different notation, we could say that x is an element from -2 to -1, and notice that it's a circle bracket at -1 because it's not inclusive of the -1, but it is inclusive of the -2, or from -1 to +2, or from 2 to +infinity, like that. Right, so two different ways to represent the domain of this function over here. So what about number 2? How is it going to be different? Notice that the denominator is the same, so we know that x cannot equal -1, x cannot equal +2, but now the numerator is the square root of x. Well, with the square root of x, notice that x has to be greater than or equal to 0, right? You can't square root a negative number, so x can't be any negative number over here. It has to be greater than or equal to 0. Whatever's under the square root has to be greater than or equal to 0. So notice that this restriction in this case, it's actually already within this restriction. Because since x has to be greater than or equal to 0, it can never equal -1 anyway. So we would just ignore that restriction in this case. And the way we would represent this on a number line, so if this was 0, this would be a solid dot. It can't be 2, so this would be an open. And then it would look like that. Right? So it's going from 0 to 2. It's not inclusive of the 2. And then from 2 to infinity. And notice that we don't include the -1 because that restriction is already within this restriction, right? So notice that it's not going to be -1 anyway because all the x values have to be greater than or equal to 0. Okay, so the way we could represent this in this notation, we could say x is an element from 0 to 2, not inclusive of the 2, and then from 2 to +infinity. Or this is an or right here, or from 2 to +infinity. Right, so showing it on a number line, showing it in that notation. And then finally, number 3, denominator still stays the same. So notice x cannot equal -1, x cannot equal +2, But notice here with this square root, basically x minus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to 3. And notice that in this case, x having to be greater than or equal to 3, these restrictions are already within that restriction, so we don't actually have to write them. Right? So basically, if we showed this on a number line, if this is 0, if this is 3, there would be a solid dot here, and it just goes till positive infinity like that. So the 2, which would be here, the negative 1, which would be here, we wouldn't have to write that because those restrictions are already within that restriction right there. And to show this in this notation, basically x is an element from 3, inclusive of the 3, to positive infinity. All right, so just wanted to go over this example because it really illustrates how you can have the same denominator on a rational function, but depending on what that numerator is, the domain can really change, and the number of elements in the domain can really change, right? So just be aware of these types of functions.